Hello, I hope you have successfully completed the lab because you need to complete it before you do this assignment so that you know what we're talking about. In that lab, just to remind you, you had 3 light bulbs. You've worked with one of them first to kind of see how a electric circuit is constructed with a battery and a switch and 1 light bulb. You also looked at how to connect a voltmeter and an ammeter. First off, how to handle a multimeter that can measure resistance, voltage, and current. There is a certain way that you could put in the prongs and which part of the dial to select in order to be able to obtain the necessary measurements. So in that lab, you looked at how adding light bulbs together creates a lower current. Also, when you played with 1 light bulb, you saw how increasing voltage causes an increased current. And today, in this video, we're going to talk about how to solve circuits or problems about circuits that are connected in series. And you see that there are 3 rules for voltage, current, and resistance. For resistors, whether those are light bulbs or just general resistors that are connected in series to a battery. So in the diagram here, you see altogether 4 different resistors. And the way they're connected is in series. How do you know that? Well, if I mark the plus and the minus, then you remember that conventional current flows from positive to negative because it's the conventional current is considered to be the direction of motion of positive charges, which we know is not really electrons, but nevertheless, so we're going to consider the motion to be clockwise, and then see how there are no junctions. So the current that goes through a 2 ohm resistor is the same current that then goes through the 4 ohm resistor, then through the 5 ohm resistor, through 7 ohm resistor, and then finally completes and comes back in onto the negative terminal of the battery. So altogether, all of these resistors added together have the same current. They all have the same current because they are connected in series. So the first question, how are these connected? They're connected in series. So that's your choice right here. Which resistor will have more current in it and why? Well, that's the trick question. Neither. All of them will have the same current because they are connected in series. And you have the rule staring you right in the face right here. Total current through the circuit is the same throughout the circuit. So neither of those resistors will have a greater current. They will all have the same current. Well, which resistor will require more voltage and why? Think about what resistance is. Resistance is just what it is called. It's the resistance to current. And the more resistive a resistor is, the harder it is to push the current through it. The more effort, if you will, the more so-called pressure. You can think of voltage as pressure. How much pressure does it take to push those electrons through a resistor? That is what resistance is all about. And the easiest, and you've all heard the expression, the path of least resistance. The path of least resistance is 2. So it's going to be the easiest to push the electrons through the 2 ohm resistor. It's going to be a little harder to push it through 4, even more harder to push it through 5. And then so when it talks about the resistor with the most potential difference or the most voltage across it, if we were to connect a voltmeter right here, the voltmeter would show us the biggest voltage on the 7 ohm resistor. That is because it's the most resistive one. It will take the most pressure. It will take the most effort to push the electrons through it. So it's going to be 7 ohm resistor, highest resistance. Okay. Now, calculate the total resistance of the circuit. Since they are connected in series, you can look at the rule, which is right here. The total, also known as equivalent resistance. So the total resistance in the circuit that has resistances in series, like holding hands. See how each one of them holds the hands of the next ones. In that case, to figure out our RE, we're just going to do 2 plus 4 plus 5 and plus 7. So when we add all of these together, then we will end up with, think about this is 6, 11, and 7. That's 18 ohms altogether. That's the equivalent resistance. Now calculate the current and see how they're trying to trick you. Well, not they, I am. In each resistor. Well, we just talked about how they will all have the same current. So when we figure out one current, we sort of figure out all currents. And to get the total resistance is what we're after, because total resistance will be equal to all the resistances in the circuit. So let me grab this, copy, oops, boom, boom, and there we go. So we will just add all the resistances right here, get total resistance, and then I total, which is the same in all. It will be V total, which will be the voltage of the battery, divided by the equivalent resistance, or resistance total, if you will. So again, our total resistance is 18, and our total voltage is 9. So we'll do 9 over 18, which is 0.5 amps. Or you can say 1/2 if you want. Either way will work. So again, even though they're talking about in each resistor, that is, we don't have to divide it by anything. This is the current in each resistor. They all have the same current. That's the rule. In series, all resistors have the same current. Take total voltage, divide by total resistance, you'll get the total current, and that will be the current in each of the resistors. And then finally calculate the voltage in each resistor. Now those guys are going to be different because they all will add up to battery. Neither of those resistors in series grab the battery all to themselves. They sort of share the battery, and each gets the chunk of the energy, if you will, the chunk of potential difference or voltage in accordance to its resistance. So this right here, the 7 one, is going to be the hog. It will hog the most voltage. And how do you figure it out? So we found that this guy will have 0.5 amps. This one will have 0.5 amps. They will all draw 0.5 amps. And then if you know their resistances, you just literally multiply these guys. So we will have voltage in 2 ohms is 2 times 0.5, which is 1 volt. Voltage in 4 ohms, you get, again, 4 is the resistance, 0.5 is its current, so that's 2 volts. Then we get to, what was it, 5? Voltage in 5 ohms is going to be 5 times the current that they all share. So, backwards. No, 0.5, not 0.2. So that's going to be 2.5 volts. And then eventually we get to final, the one that is the hog, the one that hogs most of the voltage. That's going to be 3.5 volts. Now notice that if I add all of these together now, if I add 2 volts plus 1 volt, that's 3, and then 6.5, and finally altogether they will give me 9 volts, which is the voltage of the battery. So again, for each one of these, I multiplied 2 times 0.5, 1 volt. Then we had 0.5 times 4, that's 2 volts. 0.5 times 5, 2.5 volts. So altogether, that's already 5.5. And then another 3.5. So 1 plus 2 plus 2.5 plus 3.5. all of that gives me 9 volts. Magic!